a convergence. Rate of convergence of Regula Falsi method, Regula Falsi and Secant method. Secant method. So now again, so as we define in a definition of a rate of a convergence this one is a relation between for two successive iteration. Means we try to establish the relation between En and En plus 1, then the power of a En represent what? The power of a En represent the rate of a convergence. So what is the iterative scheme of a Regula Falsi method and secant methods? Xn plus 1 equal Xn, here Xn f of Xn minus 1 minus Xn minus 1 f of Xn divided by f of Xn minus 1 minus f of X. So what's happening in a Regula Falsi method? One end is always fixed. Suppose Xn minus 1 and f of Xn minus 1 is fixed, and in a secant method both end means Xn, f of Xn, Xn minus 1, f of Xn minus 1 vary. Means if we quickly recap, what is the difference between Regula Falsi method and secant methods? Here this one is a point where the value of the function is a negative and this one is a coordinate, and here if this one is a b, f of b, and we draw a straight line here, draw the straight line and point of an intersection. Here this one is a what? This one is a next straight line, and this one is a x0, this one is a x1. So in a Regula Falsi method this end is a fixed. Suppose this one is a what? This end is a xn f of xn, and this end is a what? Xn minus 1 f of Xn minus 1. So here in a Regula Falsi method this end is a fixed and this end will vary. So you will see the difference from this end is always constant. Means this one is a Xn minus 1, this one is alpha. So error means En minus 1 equal what? Xn minus 1 minus alpha. So this one is a fixed, this one is a constant. This one does not change as we proceed. Means one iteration to next iteration means x0 to x1 to x3, x4 and so on. But this end from here to here, here to here, like this one. Means this one change from xn to x0, then x1, x2, like this one. So not xn, last one is xn, but here for sake of a simplicity we consider this one is a what? This one is a xn. So here what will happen in a secant method? Both end will vary. In a first iteration, in a secant method is a iterative method, so there is no need to check in each iteration. One value lie at one value the value of the function is a positive, at one value the value of the function is negative. In each iteration there is no need to check the means this condition of a bracketing. Condition of a bracketing method means f of a into f of b is less than 1. There is no need to check in each step. In a secant method the condition means at one value the value of the function is positive, at another point the value of the function is negative. Whatever the value after when we start, whatever the value, it doesn't matter in case of a secant methods. Means as the iteration proceeded, x0 become x1, x1 become x2, x2 become x3, x3 become x4, x3 become x4, x4 become x5 like this one. So this one is a quick recap of Regula Falsi method and secant method. Now, how we derive this expression? How we find the relation between En plus 1 and En? Now suppose En is a what? En is a positive difference between the value after nth iteration minus alpha. This one is a positive difference. Here we consider this one is a positive difference. So what is the value of xn? xn equal what? Alpha plus En. Alpha plus En. Again we take a positive difference. En plus 1 equal what? Xn plus 1 minus alpha. Then xn plus 1 equal alpha plus En plus 1. Similarly, this one is not xn plus 1. Similarly, xn minus 1 equal what? Alpha plus En minus 1. Now put the values of xn plus 1, xn minus 1 from here in this expression, means in the iterative scheme of a Regula Falsi method, or you may also say the iterative scheme of secant methods. So you may also write this one xn plus 1, this expression. What you write means xn plus 1 equal xn minus f of xn minus 1 minus xn divided by f of xn minus 1 minus f of xn. So this one is a simplified form of this one. You simply multiply by this one, then you will get xn into f of xn minus 1 minus xn into f of xn, and will be minus, then be able to find out this expression, means xn f of xn minus 1 minus xn minus 1 f of x1, this term multiplied by this term cancel out with the help of this term. So this expression equivalent to this expression. Why we write in this form? Because this one is a simplified form. With the help of this one, we easily able to find out the value of a relation between En and En plus 1. Now what is the value of xn plus 1? Value of xn plus 1 is alpha plus En plus 1. This one is the value of xn plus 1. Alpha plus En plus 1. What is the value of xn? Xn is alpha plus En. Alpha plus En. Minus, what is the value of this one? Minus, what is the value of f of xn? F of xn is f of alpha plus En, and xn minus 1 is what? Alpha plus En minus 1 minus, what is the xn? Alpha plus En. This one is what? This one is a value for xn. Now similarly, we write what? We write the value of here f of alpha plus En minus 1 minus f of alpha plus En. So here we need to find out here we try to find out the relation between En plus 1 and En. So here En, alpha and alpha cancel out. So En plus 1 equal En. Here f of x is a continuous function. So here En is a very small value. Error after nth iteration, we assume that this one is a very small value. So we expand these function according to the Taylor series expansion. What is the Taylor series expansion? We know that Taylor series expansion is what? f of a plus h is a what? F of a plus h, f dash a plus h square upon factorial 2 or 2 f double dash a, f double dash a. So this one is the expression, means this one is a what? This one is a Taylor series expansion up to infinite number of terms. Here only we write 2 terms and ignore all other terms. So there is an infinite number of terms in a Taylor series expansion. So here only we write what? Only we write 2 terms. So En minus f of alpha plus En. Here this one also cancel out. Alpha and minus alpha, this one cancel out. En, and this become En minus 1 minus En. So this one become En minus 1 minus En, and according to the Taylor series expansion, this become what? This become f of alpha. F of alpha. Alpha is a what? Alpha is our actual root. F of alpha plus En f dash alpha plus En square upon 2 f double dash alpha, and we ignore all other terms. We ignore all other terms. In a denominator also we write in a similar manner, means using the Taylor series expansion. This one become what? F of alpha plus En minus 1 f dash alpha plus En minus 1 f double dash alpha. Suppose we write only En minus 1 f double dash alpha upon 2 minus here f of alpha and this one En f dash alpha plus En square upon 2 f double dash alpha, and so on. Now, what is the simplified form of, and we know that alpha is the actual root, so what is the value of f of alpha? F of alpha become 0. This one equal to 0. And this one also equal to 0. F of alpha also equal to 0. So, if we multiply it by this one, then this become what? En minus 1 En f dash alpha, and this one En here En square by 2, this one multiplied by this one. So if we multiply this one, if we simplify this one, then what will happen here? F of alpha becomes 0, here f of alpha also becomes 0. F of alpha becomes 0 here. These terms become 0, and if multiply, we simplify this expression become what? En plus 1 equal En plus 1 equal, if we multiply it by this one, then this become what? En minus 1. So, what is the first term here? If we one step more, there is a need of a simplification of a one step more, means if we find En minus 1 plus En, here this one become En, so this term cancel out. So now what will happen here? If we simplify this one, in a denominator, there is a need of to write one step more. So here we write En minus En minus 1 minus En f of alpha becomes 0. This one En f dash alpha plus En square by 2 f double dash alpha divided by what? Divided by here f dash alpha. Here we take common, this become En minus 1 minus En minus 1 minus En and f dash alpha. And second term, what will happen? This become f double dash alpha. So this become En minus 1 by 2 ka whole square. Here this one is a whole square. So plus what? En minus 1 by 2 ka square minus En by 2 ka square. What? F double dash alpha. Now here this one is a 1 by 2 outside is n minus 1 square minus En. So a square minus b square equal what? A plus b and a minus b. So simplified form of this one is a what? En plus 1 equal En. This term cancel out. So this become what? En minus En f dash alpha plus En square upon factorial 2 f double dash alpha divided by f dash alpha plus En minus 2 n minus 1, yeah, 1 by 2 outside. Here we write 1 by 2 outside. So we write outside 1 by 2 outside. So inside what value become? En minus 1 plus En f double dash alpha. So if we simplify more, this one become what? En plus 1 equal multiplied by this one, then this become En f dash alpha plus, here we write this one 1 by 2 multiplied by this one, then this become En minus 1 plus En square multiplied by the En, then this one is the what? F double dash alpha minus this one, this term En f dash alpha minus 1 by 2 En square f double dash alpha divided by same term, this one. So if we write this one, so this one is a what? F dash alpha plus 1 by 2 En minus 1 plus En f double dash alpha. So now this one is in a simplified form. So now we try to explain means of a secant method. Although the expression become very lengthy, but it's not a very time consuming. So here, now almost be done the simplified form of expression. So this one cancel out by this one, 1 by 2 En square f double dash alpha cancel out by this one, and this one cancel out. So what is the remaining expression? Now remaining expression become what? En plus 1 equal, in a numerator, what is the value? Value become 1 by 2 En minus 1 f double dash alpha. This expression 1 by 2 En minus 1 f double dash alpha. So what is the value in a denominator? The value in a denominator is a what? F dash alpha plus 1 by 2 En plus 1 plus En f dash double dash alpha. So we may simplify this one also, and in a two-way. Here we take f dash alpha common, and here we write if f dash alpha is a common, then this become what? En plus 1 equal 1 by 2 en minus 1 f double dash alpha divided by f dash alpha into 1 plus 1 by 2 f double dash alpha upon f dash alpha, and some terms, this one is a minus 1. So this one is the resultant expression, and this one is our means for this expression is needed to define rate of a convergence of a Regula Falsi method and rate of a convergence of a secant method. So only we write the first term of this expansion. So what is the first term of expansion of this expression? This one is what? En plus 1 equal 1 by 2 en minus 1 f double dash alpha upon f dash alpha. So this one is a one term, and we ignore all other terms. Now we try to define the rate of a convergence with the help of this expression 1. So, and this expression we obtain from where? We obtain from the iterative scheme of Regula Falsi method and secant methods. So, as in a starting of this lecture, we define in a Regula Falsi method, one end is a fixed. One end is a fixed. One end is a fixed. Only one end when one end is fixed. This end is a fixed. Suppose this one is a xn minus 1 and this one is alpha. So this difference en minus 1 is a what? Positive difference xn minus 1 minus alpha. This one always constant. This one does not change in a case of a Regula Falsi methods. So what is the value of en minus 1? So the value of en minus 1 is a what? Constant. The value of en minus 1 is a constant. Why this one is a constant? Because one end is a fixed. If one end is a fixed, then the difference from the actual root, this one is a fixed, this one is a constant, this one does not vary. So this one is a constant. In a Regula Falsi method, this one is a what? Constant. Constant. If this one is a constant in a Regula Falsi method, Regula Falsi method, Regula Falsi method, because one end is fixed, because one end is fixed, and error become what? Constant. So this expression become, in case of a Regula Falsi, this expression become what? This expression become en plus 1 equal 1 by 2 en, and this whole constant because en minus 1 is also a constant, f double dash alpha upon f dash alpha is also a constant. Suppose this one is a what? C. We denoted this one is a what? This one is denoted by the C, by a constant C. Here we assume that this one is a what? C. Then 1 by 2 en C, where C is a what? C is a 1 by 2 en minus 1 f double dash alpha upon f dash alpha. And if we denote this one is a, and here en minus 1 is a not a variable, en minus 1 is a what? En minus 1 is a constant. So whole term is a constant. Now we compare this expression with what? If we compare this expression with the definition of a rate of a convergence, what is the definition of a rate of a convergence? En plus 1 mod of a en plus 1 is less or equal to C into mod of En to power k, En to power k. Then k represent what? K represent the rate of a convergence. Now here, what is the value of a k? Here the value of a k is a what? 1. So the value of a k is a 1. So what is the rate of a convergence of a Regula Falsi method? Rate of a convergence of a Regula Falsi method is a 1. And what is the asymptotic error constant? Asymptotic error constant is a what? Asymptotic error constant, this one is Fc is a 1 by 2. If here we write 1 by 2, so this one is a what? This one is not a 1 by 2 here. Because here we mentioned already 1 by 2, we consider this one also 1 by 2 in a concurrently. Means concurrently 1 by 2 En minus 1 f double dash alpha equal to C. Then this one is our expression. En plus 1 equal En C. And what is the power of a En here? The power of a En is a what? The power of a En is a 1. So what is the rate of a convergence of a Regula Falsi method? Rate of a convergence of a Regula Falsi method is a 1. Now, how we derive the expression means a rate of a convergence of a secant method from this expression. So as we described, so this one is the expression. Once again we write the expression of a what? Expression of a what we derive. En plus 1 equal what? 1 by 2 f double dash alpha upon f dash alpha into En minus 1. This one is the expression that we have derived from the iterative scheme of a secant method. So in a secant method what will happen? Both ends will vary. Means if this one is a x0, x1, in a next iteration we find this one is a x2, then x2 to x1, then x3 to x3, this one is x3, then x3 to x2, x4 to x3. Means first we find from x0, we find x1 with the help, x2 with the help of a x0 and x1. We find the x3 with the help of a x1 and x2. We find the x4 with the help of a x2 and x3. Means both end will vary. This end also vary and this end also vary. Both end varies. If both end varies, then you cannot say En minus 1 is a what? En minus 1 is not a constant. En minus 1 is not a constant. Here En minus 1 is also treated as a variable. So if En minus 1 is also treated as a variable, then here we write what? En plus 1, suppose this one is a C. C En minus 1. So if we compare with the definition of a what? Definition of a rate of a convergence. So mod of a En, and if we write mod of a En, this one is a less or equal C En to power k. En to power k. So here this one is a modulus value, and here we consider this one is a positive difference. This one is also a positive difference. This one is also a positive difference. So we there is no need to write here modulus because this one is also already a positive difference. So if we replace this one is not a En, this one is En plus 1. Sorry. So mod of En k. So here if we write En minus 1, here I am not writing the modulus because this one is already a positive difference. En minus 1 is a what? En minus 1, for sake of simplicity we consider this one is equal. Then this one is a C, and here in place of a n, here we write n minus 1. Sorry. In place of a n, if we write a n minus 1, so n minus 1 plus 1, this become En. En equal C. Here En minus 1 to power k. So if we simplify this one, what is the value of En minus 1? Here En by C equal what? En minus 1 to power k. What is the value of En minus 1? This one is a what? C to power minus 1 upon k into En to power 1 upon k. So here we put the value of En minus 1. So if we put the value of En minus 1 here, En plus 1 equal what? C En into C minus 1 by K into En to power 1 by K. Why here we write in term of En minus 1 in term of En? Because we try to find out the relation between En plus 1 and En. So now this one is a relation between En plus 1 and En. Now we try to simplify this one. En plus 1 equal what? C 1 minus 1 by K. So with the help of these two terms, and this one become En 1 plus 1 by K. So this one is a relation between what? This one is a relation between En plus 1 and En in case of a what? In case of a secant method. Secant method. Secant method. Secant method. Now we compare with the standard result. What is the standard result? Mode of a standard definition of a expression of a standard definition of a rate of a convergence. En plus 1 is a lesser equal to C mod of En to power K. So here this one is already a positive difference, so there is no need to consider means a modulus value. This one is also a positive difference. So if we compare these two expression, this expression and this expression, so what is the value of a K? Here 1 plus 1 by K equal to K. C equal C1 minus 1 by K. So our interest is to find out the value of a K. Now what is the value of a K here? If we compare these two results, means by the definition of a rate of a convergence and what expression we find with the help of a iterative scheme of a secant methods. So what will happen here? 1 plus 1 by K equal to what? K. If we simplify this one become K plus 1 equal to what? K square. If we simplify this one, K square minus K minus 1. This one equal to 6. So if we simplify this one, what is the value of a K? Because K represent what? K represent the rate of a convergence. So this one is a what? Minus 1 plus minus 1 means minus B. This become plus 1. Here become minus B. Here B with the minus 1 plus minus under root B square is a what? Minus 1 K square 1 plus 4 AC. Minus B plus minus under root B square minus 4A is a 1, C is a minus 1, so this one is a 4 divided by 2A minus B plus minus under root B square minus 4AC divided by 2A. A is a 1. So if we consider the minus sign, because under root 5 is a greater than 1, so this become negative. So rate of convergence cannot be negative. So only we consider what? Positive sign. Why we not consider the negative sign? Because the rate of convergence become negative. So rate of convergence cannot be negative. So rate of convergence always positive. So what is the rate of convergence? So here we consider only the positive sign. So K equal what? Minus 1 plus 1 under root 5 divided by what? 2. So this one, if we simplify this one is a 1.618. So K equal to this one. This one is the value of a K. And K represent what? K represents the rate of a convergence. So what is the rate of a convergence of a secant method? Rate of a convergence of a secant method is a 1.618. So this one is the rate of a convergence of a secant method. And what is the rate of a convergence of a Regula Falsi method? Rate of a convergence of a Regula Falsi method is a 1, and rate of a convergence of a secant method is a 1.618. So it's clear, it's a very clear. The rate of a convergence of a Regula Falsi method is a 1, and rate of a convergence of a secant method is a 1.618, and why we derive concurrently, there is a one is a bracketing method and one is a iterative method. In a one method, one end is fixed. In another method, both ends will vary. So accordingly, the rate of a convergence, and it's also means clear from the geometrical interpretation. If one end is fixed, only one end vary, then obviously the rate of convergence is less. If both end will vary. If we started from here and started from here, only one end vary, only one end move, then obviously the rate is less. If both end vary, then obviously the rate of a convergence is high. So this one is all about rate of a convergence of a Regula Falsi method and rate of a convergence of a secant method.